Hello everyone and welcome back. Today we are going to talk about roundness or circularity, definitions, methods, and an example on gum inspect. So let's get right to it. So I've made some research on the internet and put together some information about the roundness. Let's see in this presentation what roundness is all about. Okay, so roundness is the condition imposed to a cylindrical, conical or revolution surface to have all its points from any cross-section perpendicular to the axis, equidistant to the axis. And we can see here in the cross section, so this is this is any cross section from the cylinder. So this is the real circular profile. This is the adjacent circle. The adjacent circle, this is the reference circle. So when I say adjacent circle, I mean the reference circle. Okay, and the A is actually the tolerance. Is actually the roundness deviation, maximum permitted deviation between the real circular profile and the reference circle. And here we have the formula. Okay, so roundness represents the maximum distance, the maximum peak to valley from the real circular profile and the adjacent circle, the reference circle. The tolerance zone is formed from two concentric circles where all points from the real circular profile must lie. So we have here some examples again. This is the tolerance zone right here. This is the points taken on the profile of the circle, here as well, tolerance zone, and here again the tolerance zone just for this section of radius. This is a radius, but you can do roundness even on a small portion of a circle. Roundness measurements are used to evaluate and control the quality of cylindrical objects. Methods used for determining the roundness are the least square circle, the maximum inscribed circle, the minimal circumscribed circle, and the maximum zone circle. Okay, so we have here an example. Okay, and long story short, because you can see it very well, but long story short, if this circle, for example, had maximum radius of 14.58 and a minimum radius of 9.74, then the roundness will be this 4.84. So it's the maximum radius minus the minimum radius, and this is the result right here. And now let's take each and every one of the methods and explain it. So first we will take the least square circle. It's a circle which separates the roundness profile of an object by separating the sum of total areas of the inside and outside in equal amounts. The roundness error then can be estimated as the difference between the maximum and the minimum distance from the reference circles. Okay, the next one is the minimum circumscribed circle. It's defined as the smallest circle which encloses whole of the roundness profile, where the error is the largest deviation from the circle. Then we have the maximum inscribed circle. It's defined as the largest circle that can be inscribed inside the roundness profile. The roundness error here again is the maximum deviation of the profile from the inscribed circle. And the last one, and the most used one, minimum zone circle. Here two circles are used as reference for measuring the roundness error. One circle is drawn outside the roundness profile just as to enclose the whole of it, and the other circle is drawn inside the roundness profile so that it just inscribes the profile. The roundness error here is the difference between the radius of the two circles. Okay, so let's make a roundness check on GOM inspect on the GOM part. Okay, so there are two ways of doing this. You can do it by making a cross section anywhere on the cylinder. So we will use this cylinder right here, or you can use it to do a roundness on the whole cylinder, so you can see the roundness on any cross section from the cylinder. So we will do both of them right now. So first you have to make a section on the, if you want to make a cross section, you have to make a section on the cylinder wherever do you want. Okay, so go to construct section, single section. Okay, now you will have to select the surface that you want to make the section on, and since I only want to make to select the exterior of the cylinder, I will go to deselect on surface or control space from the keyboard, and I will try to select. Okay, then again so when you have the selection that you want to make, right click, then you will get three icons. This is for adding the surface, this is for deselecting, and this is to cancel. So just make sure you are on add and take your hand off the right mouse button. Okay, seems okay. Now we just have to say to the section that we want to do it here, and it looks very good. Create and close. Now we have a section, but we have to put the measuring principle, reference construction. Okay, and I didn't take it the whole contour, but it's fine, we can use it as it is. And now we want to do a circle, so go to construct, go to circle, fitting circle, and control click on the section, and you will get the circle. Create and close. And now we can put the measuring principle, fitting element. We will do it as let's see, shabby chef best fit. This is the minimum zone circle. Usually I work like this when I do roundness, so it's okay. This or best fit, but it's better to use minimum zone circle. Okay, I don't think it's a very big difference on the part that we have here. I already made some tests and we didn't have any difference in the results. Okay, so let's see the circle right now. Let's make a roundness on the circle. Go to inspection, go to GD&T check, and we have here roundness. So let's put 0.1 tolerance on the roundness and hit OK. And we can see that it's exactly 0.1. And let's see exclusively this roundness. So let's hit E on the keyboard, and now let's go here and go to GD&T roundness tolerance and see the roundness. Okay, so yeah, we cannot see the tolerance between them, but we can make it bigger and we will see it. Okay, so tolerances, let's make the tolerance 10 millimeters. 10, okay, yeah. So this is the tolerance from here to here. The points have to lie between here to here, and this is the reference circle. Okay, so let's set it again to 0.1. Okay, and let's display color deviation, and let's set this to 100. Okay, so vector scaling to 100, and as we can see, this is what the profile of the circle, of the real measured circle, looks like. And let's set the limit values to the histogram to 0.1 as we have it in the tolerance, and we can see right here the deviations. Good. Okay, so in order to see the cylinder, the roundness to the whole cylinder, we will go to construct, cylinder, fitting cylinder, control on the keyboard, and right click on the surface of the cylinder. Now create and close, set the measuring principle again to fitting element. Let's put it again to Chebyshev. Okay. And now that we have the cylinder, we can go again to inspection, check GD&T roundness. And we can see that the roundness this time is 0.18. So it added 0.08 millimeters on the deviation. Okay, and let's see this exclusively. Okay, GD&T roundness. Okay, good. Again, let's set tolerance to 10 so you can see it better. So now is the whole cylinder. Good. But we will set it again to 0.1. And let's see the color deviation representation. Let's set it again to 100. and on the histogram to 0.1, and now we can see the deviation from the whole cylinder. And let's set this to small. Yeah, it's way better. Okay. Yeah. So this is what we can do in GOM Inspect. As you see, this is a beautiful representation of the roundness from this cylinder, and I think it's very explicit, and you can show it to your customers or to whoever asks to evaluate the roundness profile of cylinders, of holes, or anything. Thank you for watching. Please support my channel with a like and a share, and if you like my content, subscribe. Until next time, have a nice one.